The unit circle is an idea that's going to come up a number of times throughout this year. And by a number, I mean a large number. So it's going to be very important that we understand the patterns behind it and how we'll be able to use it in the future. So what we're going to do today is look at how some special right triangles that you learned about in geometry and algebra 2 can be used to remember or illustrate some of those special angles on the unit circle. So the first thing we're going to look to do is draw a unit circle. Now we could use a tool or print one out, but I'd like to make sure we get used to drawing them by hand because it's going to be a helpful skill in the future. So we've got our unit circle. It doesn't have to be perfect, but it's nice to get that started. What we're going to do is look at the first quadrant, 3 specific triangles. Draw my red triangle, I'm going to draw this blue triangle, and I'm going to draw a green triangle. And we're going to look at how each of these 3 triangles are triangles that you've really seen before in the past. First, let's look at this red triangle. The first unit circle angle that we look at is pi over 6, which you should at this point remember is similar to 30 degrees. It means that this angle here from the x-axis to the terminal ray is 30 degrees. I've dropped each of these altitudes of the triangles to make a right angle, which means this is a 60-degree angle. Since this is the unit circle, the hypotenuse of every triangle that extends from the origin to the outside of the circle will be 1, because it's the radius of the unit circle. In a 30, 60, 90 triangle, if you know the hypotenuse, you know the side across from the 30-degree angle must be half that length. And the side across from the 60-degree angle should be the new length we found, a half, times the square root of 3. And we're usually going to see this written as the square root of 3 over 2. And that is why this angle is given the coordinates of square root of 3 over 2 for the x and a half for the y. And those we'll see later are the cosine and sine values of that angle pi over 6. The same ideas can be applied to the blue triangle, which is a pi over 4, which is similar to 45-degree angle, which means that we have a 45, 45, 90 triangle, or an isosceles right triangle with a hypotenuse of 1, which means that these two sides, the legs, must be in a ratio of x square root 2 to x. So if 1 is equal to x square root 2, that means that x is equal to 1 over square root of 2, which we can rationalize to square root of 2 over 2. And that is why it has the coordinates square root of 2 over 2 for x and square root of 2 over 2 for y. And this green triangle is actually the same triangle we just saw earlier in red, turned on its end. Hypotenuse of 1, it's a pi over 3 or 60-degree angle, a 90 for our altitude, 30 degrees here, which means that this side will be root 3 over 2, and the bottom length will be 1/2. So the coordinates here are 1/2 for x, square root of 3 over 2 for y, and you can use any of these triangles, red, green, or blue, to create any other special right triangle in the unit circle whenever you'd like. All you need to be careful of is whether or not the x and y coordinates should be positive or negative.